Hey guys, I'm gonna do a demo of Altos. This is gonna be a complete demo. I'm gonna try and go as fast as I can so you can see all the features. And yeah, so Altos is a complete sky system. It's for Unity. It's designed only for Unity URP. To add it to your project, you need to go to your universal renderer data and add the Altos render feature to your project. You also need to make sure that you have a sky director in your project as well. The sky director is the Altos sky director, like that. You can see that I'm in play mode. If we move around in play mode, you can see that we have some different effects going on. So Altos includes volumetric clouds, day-night cycle, star rendering, visual effects, ambient effects, the clouds you can fly through. Everything that you see in the scene is included in the demo. And it also includes cloud shadows and fog. So you can see if we set this to something quite large, 40,000. So that's our sky fog. It blends perfectly with the atmosphere. So I'm going to quickly go through the different features for Altos after going through a quick getting started. So to get started, you, like I said, add Altos render feature. If you don't have your render objects set up correctly, you're going to have some problems with how Altos renders transparent objects. So for example, let's see if we can find something in here. Nothing wants to render for me right now, so let's jump in here and see why this doesn't want to render. Great, so you can see that these are not rendering properly when the render objects feature is disabled. So you need to make sure that you have that enabled. And that's just for the sky objects, the sky transparent objects. In order to set that up, you'll go to your universal render data, go to your transparent layer mask, disable transparent FX, then add the render objects. Make sure that you tag it to after rendering opaques, set the queue to transparent, layer mask to transparent FX, and the light mode tag should be kept empty. As you can see, the VFX comments, for example, is also set to the transparent FX layer. As you can see that the VFX has a component attached to it. We'll go through that a little bit later. First, we'll go through the sky director. So the sky director consists of four major pieces: the sky definition, atmosphere definition, star definition, cloud definition. It also has a resources file that includes all the different shaders, textures, and meshes that Altos needs to work. So you need to make sure you have that in your project. The sky definition is used to configure the current time of day. So you can slide through that. You can see that we have some cool auroras going on as well. The initial time, so that's the time that the game starts when you hit enter play mode, and the day-night cycle duration in hours. So if you set it to 0, then it'll not move at all. Then if you set it to 1/60th, you'll go through an entire day in 1/60th of an hour. I'm gonna go ahead and set that back to 1. Then we have the period of day keyframes. The name doesn't matter, it's just for your use. Basically, Altos will automatically interpolate between each one of these as it moves throughout the day. So if we go ahead and cycle back to 4, then you can see that we're at the night end keyframe. And then as we go from 4 to 6.8, you can see that we go to the dawn keyframe. You can set the start time, the sky color, the equator color, and the ground color for each one of these. These are used automatically by the clouds and the sky, and it's also applied automatically to your lighting, environmental lighting options. So these are automatically set from your time of day options. You also have your environmental lighting options down here. You can control the exposure. If you want to make it really bright, you can. You shouldn't. And you can control the saturation if you want to make it super saturated or not. I'm going to go ahead and pause this for now. The next thing that we're going to look at is so this current time just maps to the current time that I was showing you in here. So it's the exact same field. It's just shown here for ease of use. You can see that there's some sort of glitching going on here. It's not glitching. Basically, Altos uses temporal anti-aliasing and reprojection to make the clouds look really nice. As you can see, they look really nice. When you're changing the time pretty rapidly, the system has trouble keeping up. So just keep in mind that you will need to change the time pretty slowly. But you can also control the temporal blending factor from the cloud settings. So before we get to there, we're going to go into the atmosphere definition. This one's pretty straightforward. It just controls the fog blending. This fog blending works with the actual skybox. So if you see here, if we go into our frame debugger, you can see that we actually render our sky as a mesh. And so that's just our sky texture. Then we sample from that texture in order to have pixel perfect fog blending with our sky, no matter what time of day. And you'll also see that, you know, things like our sun come through looking beautiful as well. So that's our atmosphere definition for your stars. You can configure the stars. The stars are each rendered as individual sprites. So if you zoom in really far, you can see that, you know, I mean, I just zoomed in like that. It's probably not the best way to do it. Maybe we'll use the field of view instead. You can see that these are, you know, individual sprites that we're rendering. And they're rendered using a compute shader. You can change the count on the fly. Don't make it too high. It automatically, you can set the color automatically, or you can set it yourself. You can set the brightness automatically, or you can set it yourself. You can set a texture. I include a bunch of different textures that you can choose from. And you can set a colored tint. This tint will apply whether or not you're using automatic color. You can also control the brightness during the day, the brightness at night, and how frequently the stars flicker and the intensity of that flickering effect. So if you set it really high, you can see that they flicker a lot. You can also control the size of the stars. Cool. If you're going to make them really big, I would recommend using a texture that is bigger than 32 pixels. Yeah. So the stars automatically move when you're changing the time. That's really cool. If you don't want that to happen, you can set the position to static. Now when you change the time, the stars will not move. You can also control the inclination of the stars. This basically affects how they're offset relative to the baseline. I'll go into inclination a little bit more as we get into the sun and moon objects. And then we go into the cloud definition. So this one has a lot, it has 3 tabs: common, low altitude, high altitude. The common settings apply in general to the clouds overall. The low altitude apply to these lower altitude clouds, and the high altitude applies to these high altitude clouds, which you can see better during the day. And if we just bring that up a little bit, you can see that we have some clouds here. So these are our high altitude clouds. So you can control the high altitude clouds using a texture. So it's a weather map texture, kind of controls generally where are they. The cloud texture 1 and cloud texture 2. So these are all for the high altitude. In the common settings, we'll just jump back here. You can control a step count. This affects the overall quality of the clouds. You can see that when it's quite low, the clouds get kind of noisy and dithery. So don't set it super low. Here it's at 6. It's very low. I recommend, you know, at least 32. 128 looks really nice. You can control the noise intensity. I recommend keeping this at 1. You can control whether or not it renders in scene view, which is currently not working. And you can disable or enable TAA, which is also you know, helpful, but I would always recommend keeping TAA enabled. And then you can also set subpixel jittering enabled as well, which helps to slightly increase the quality of the clouds by jittering the samples at a subpixel level. The TAA blend factor controls how quickly we integrate between the previous sample and the current sample of the cloud texture. So I'll just jump in here really quick to the frame debugger. You can see that we render the clouds to a texture. And so when we render those clouds to this texture, we then integrate this texture over time. Here's our temporal integration target. And you can see that you know, if we change the temporal blend factor to something really high, then it'll integrate more quickly, which means that there will be more noise. So don't do that. You can see here, this is with it set all the way to 1, so basically no temporal integration. There's a little bit of noise, and then as we bring this down, the noise increases dramatically. Next thing we're going to look at is lighting. So you can control the sun color. This is like a tint on the sun color. You control the ambient exposure, so you can make it, you know, really bright or not very bright at all. It automatically uses the ambient lighting from your sky definition. You can use cheap ambient lighting or expensive. You can see the expensive one looks, a little better, but it is quite a bit more expensive, so that's on you. And you can control Henny-Greenstein scattering, which sort of looks like this. So you can see that when it's fully enabled, then it casts this sort of strong lobe of lighting in the direction of the light. And we have a forward scattering term and a backward scattering term. Basically, these let you, kind of adjust the way that the clouds look. In general, the default settings are pretty good. If you want, you can tighten up the scattering by bringing this lower, and same thing for the backward scattering. So let me show you that. So you can tighten this up as well. If you bring it all the way down, it's quite tight, and then if you loosen it up, it's less tight. And then we're going to look at the atmosphere, so you can control the sort of planet radius that affects the curvature of the clouds. So if we go somewhere that has a small planet radius, like Enceladus, you can see the clouds sort of starting to skim down here. It's a lot easier to see if we bring this cloud distance way up. You can see those clouds starting to arc down. In general, using the Earth is a pretty good baseline. As we zoom out, you can see that the clouds start to look a little bit funky in some places. So just keep that in mind. That really small planet radius doesn't work super well for some things like the high altitude clouds. But in general, it works pretty well when you're using larger values. So it's kind of designed to be a physically based system. So keep something like the Earth, Mars, Venus. Subtle changes, but it's nice to have these defaults on hand if you're making something on a different planet. That way you don't have to look it up like I did. You can control the cloud layer thickness. So if you increase the thickness of the cloud layer, you can get these really tall, cool looking clouds. The upper layer clouds are also actually rendered in 3D. I'm just going to fly all the way up there. And you can see that these clouds are just fully in the sky. They're quite high up, so you probably won't get to them. And that's where they are. And then the cloud altitude controls how high up the clouds are. The baseline is 0, can't go below that. And you can bring them as high as you want, but in general, you should use a value between 1 and 2, since that's how high clouds are normally, unless you're using like floating point offsets. So I'm going to go ahead and set this back to, let's say, 1.2. And then we'll bring our cloud layer thickness to something more reasonable, like, let's say 2. And you can see that something cool that happens if we bring it quite far down is that the clouds render in front of scene geometry. So that's really nice. And you can fly through the clouds if you want. And you can control the maximum distance at which you render the clouds. So bringing this all the way in causes the clouds to not render very far away. And then bringing it up makes them render further and further away. The visibility controls how the fog affects distant clouds. So if you bring that way up, you can see that there's no fog applied to the clouds. I like keeping it at around the same as the max distance, and I think a max distance around 20 is more than enough. You can enable or disable cloud shadows. So cloud shadows will be applied to the entire world. There's a way to sample them directly using shaders, but in general, I recommend just using screen shadows, which is a lot easier. Unfortunately, it doesn't work very well with emissive objects. So if you do want to use them with non-emissive objects, then I would recommend using the shader approach. Just be aware that there will be some extra setup steps, and it'll be in the docs. You can control the resolution of the cloud shadows. As you can see, there's like a little bit of a jump there as I switch it over. It's because the cloud shadows uses temporal integration as well to have really nice looking cloud shadows. You can see that we can bring that intensity down a little bit. So that it's a nice subtle cloud shadow feature. And now jumping over to the low altitude. So low altitude clouds have quite a few different options. I'll go through them now. So the extinction coefficient controls how dense the clouds are. If we make it really low, the clouds go away. As we increase it, the clouds become more and more and more and more and more and more dense. So you can get really super dense clouds with this feature. I'm going to bring it back to, I don't know, something reasonable like 100. The cloudiness affects the overall cloud scape, like how many clouds are there in the sky. You can preview the cloudiness by going to Window, Focus Software, Altos, Cloud Map Preview. So this shows you the red channel, shows you how cloudy it is. It's centered at the origin, and this is just sort of sampled automatically. It doesn't change when you change this. And then the green is the precipitation map, which we'll talk about soon. The cloudiness density influence controls how the cloudiness density changes as the cloudiness changes. If you set it to 0, then the clouds don't become less dense as you change the cloudiness. If you set it to 1, they become less dense as you change the cloudiness. And the height density influence controls whether or not the clouds become less dense at the bottom or not. The height density curve allows you to move the cloud shape around. So if you want, this is, the bread and butter of where you can set up weird looking, funky looking cloud shapes. I like my default. I think it looks nice, but you can set up some really interesting cloud shapes if you want, like this. Wow, flying through the clouds, so cool. Now imagine doing that with a plane. That'd be fun. Cool, so I'm gonna go ahead and delete these and go back to our normal clouds. There's a distant coverage option. This controls how cloudy it is in distant parts of the map. So if you want it to be not very cloudy nearby, but more cloudy far away, then you can use this option to make it cloudy far away. You can also control the maximum lighting distance. In general, you don't need to touch this. Lowering it makes the clouds check less far away to do lighting calculations. As you can see, if it gets too close, then then the clouds become pretty inaccurate at like estimating lighting. If it's really high, then the clouds also become quite bad at estimating lighting. So keep it something reasonable, probably something close to your atmosphere thickness. You also have multiple scattering, so this adds some additional depth and color to your clouds. You can control the intensity of that value and the density gain of that value. Let me go ahead and, yep, okay, cool. So the next thing that we're going to look at is the weather. So for the weather map type, I like to keep it as procedural. So that's just using the procedural, Perlin noise texture that we generate during runtime to generate the cloud map. For most games, this is good. You can control the number of octaves of noise. So if you make it quite low, it's easiest to preview this from above. If you make it quite low, there's not too much detail going on here. But if you bring it up a little bit, then you get a lot more detail in the cloud shape. The gain controls how this sort of attenuates over each octave, and the frequency controls how how the frequency changes. Then you can control the scale as well. You can see that some of these aren't moving. These are precipitation zones. I'll go ahead and let's see here. Let me go ahead and disable our precipitation zones so that we can properly play around with our clouds. So these are different octaves. Cool. And let's go back to a nice scale of something like 3. You can control the wind speed to make the clouds, move. It's not working in this demo. I'm not sure why. I'll have to take a look, but it also works with a wind zone. So if you use the wind zone, you can see that you can make it move. And our wind zone is pointing that way. So if you increase the main wind speed, then it'll move that way. And then depending on where you aim it, it'll cause the clouds to move in that direction. So that's super cool. Really like that integration. And then if we jump over to, There we go. We jump back over here, and then we disable our cloud velocity. You can see that it's now working normally. And you can control the X or the Y speed. And this is handled on the CPU side, so you can share it across different multiplayer games if you want to have the same cloud position for different clients. You can change the cloud type, so you can choose between Perlin, Perlin Whirly, Whirly, or Billow noise. I think they all look quite nice, quite unique. And you can change the scale of that noise. Jump down here. You can change the scale of it. Try to make the values, pretty intuitive, something between 0 and 10. You can control the detail noise as well. And you can control how it maps over the height. So if you set it to 0 to 1, then it'll attenuate from basically a value of 0 to an intensity of 0.3 or 0.1 as you increase the height, and so on. So here we're seeing it, kick in straight away. I think something like that looks nice. And you can control the scale of that effect as well. So something subtle looks good. You can move that. And you can move the Perlin noise as well. And then for the curl noise, you can move the curl noise around. And so this basically makes the clouds kind of wiggle. And so that's clouds. Great. So we went through skybox, atmosphere, stars, clouds, the data asset, covered all of that. Now I'll take a look at the sky objects. So for our sky objects, we have this fun gizmo. So the sky objects automatically move as we change our time of day. Excellent. These orbits show you how they will move through their orbit. Currently the sun has an angular diameter of 0.52 degrees, an orbit offset of 0 degrees, an inclination of 23.5, an orientation offset of 0 degrees, and an intensity of 2.3. You can see as we move the sun, the intensity changes. So when the sun is below the horizon, the intensity goes down to 0. So pretty cool. If we jump into the sun itself, you can see that it's a sky object. So you need to have a sky object component here. You should only have one sun. The angular diameter degrees controls how big it actually renders in the sky. So let me go ahead and hide our clouds for us for a moment. Great. So if we increase that, you can see that the disk gets really large. As it gets large, you can see that the edges of the disk are darker than the center. That's because we use limb darkening algorithms. That's how the sun looks in real life. So that's how it looks in Altos. You can apply a texture if you want. I'm just going to apply this silly one. And then if we make it bigger, you can see that it's applied the texture. It will still clip around the edges because we're using a radial gradient. So something to be aware of. And you can control the color tint as well. Cool. Excellent. So where did this go? So as you can see, the sun is having a little problem here. So here's our sun again, and you can make it bigger or not. You can also choose to use an automatic color. If you use an automatic color, Altos will automatically set the color based on a curve between the base color temperature and the maximum color temperature. So that'll help you get a more realistic look in your game, and you can use a color curve adjustment to control how it interpolates between those two factors. And you can also use automatic brightness, so it'll automatically reduce the brightness as the sun goes down below the horizon. You can enable or disable that. You can control the curve over which it does that, as well as the peak intensity. And you can tint the color if you want. The sort order controls how the sun is oriented relative to the center. So for example, if we set this object to have a sort order less than that of our moon object, if it renders in front of the moon object, then it'll basically eclipse the moon object. You can control the orbit offset. So that'll push this, around the orbit. In general, your sun will have an orbit offset of 0 and your moon will have an orbit offset of 180. You can control the inclination, so that's like how offset it is, and the orientation of the orbit. You can also set it to static, in which case it'll never move. It'll just always be fixed exactly where you set it. So that's nice as well. And then you can control the sky fall off, which is this option, to affect how it influences the sky color. And then you can also control the color of the handle. And this one should have a directional light. So moon is pretty similar. You could apply your disk. You can change the type. The type should be other. And you can choose to use, whatever colors you want, whatever fall off you want, and so on. So let's see if we can bring the moon up for us. And so that's our moon. You can control the fall off. Set the position to static, whatever you want. Okay, so that's all of the core features. Next, we're going to take a look at some of the demonstrations and some of the VFX. So the first VFX that I'll show you is the precipitation. You can see that we have this rain and snow following our camera around. I'm going to disable the snow really quick. So you can see here we have our rain. So what's going on, right? Let's see here. So here's our camera. We have our rain following it. So the rain has a weather effect component on it. That weather effect expects a visual effect, so from VFX Graph, as well as a reference to the Sky Director. It'll generally follow your main camera, and you can control the offset of the VFX relative to your main camera. And you can control the some VFX options. So those options include whether or not it uses the wind zone. So if we enable our wind zone and pump up the intensity, you can see that it's blowing our rain around in our scene. Go ahead and disable that. And the precipitation amount. So the precipitation amount comes from this value. So this value is set by looking at the cloud map preview, and in the cloud map preview you can see that we have our precipitation weather state in effect. So let's go ahead and turn that off, and then magically the rain stops. And then if we turn it on, the rain starts up again. So these green sections show where precipitation is occurring in your cloud map. And our weather effect script automatically looks at this cloud map and enables or disables the precipitation based on that effect. This works for both rain as well as snow. So if we turn off our weather system, the snow takes a little while to peter out, but it will. And you can see it disappearing now. And the way that you can observe the weather state is if we just turn our clouds on just a bit. You can see that right here we have our precipitation zone. And if we turn our precipitation off, then our VFX also stops. And you can see that that effect is synced up with our clouds. You can control the radius of this effect. And whenever the camera is anywhere within this zone, the rain zone, then you'll have rain being cast on the camera. We have this other zone over here, and so that one's this one, and you can move these around as well, right? So we're just gonna move this around to 3000. You can see it moving on the cloud map preview. You can see it moving in the world. The Y doesn't do anything. This is a top-down sort of projection, and the Z moves it left and right. Let me see. Okay, cool. So you can see some lightning effects happening as well. As of right now, the lightning is not synced up into the precipitation system, so you will need to manage that somewhat separately. And basically what we have here is this VFX graph. It's spawning in this axis aligned box, and when it spawns, it initializes a point light, very bright point light, which we can see best if we make it dark out. And that point light also illuminates the clouds. So if we go over here and we turn our clouds on, and then we ramp up the frequency of our, let's go ahead and turn our wind zone off. So if we ramp up the frequency of our lightning, let's say we're spawning a lot of lightning, you can see that it's illuminating the clouds in a really cool way. If you make it too high, it'll start to have some problems. So try to keep it at something reasonable, like 3 or 4. And yeah, it looks really cool. It illuminates the clouds. If we zoom out here, you can see it illuminating the clouds from above. Looks really super cool, and I think that you guys will really like this system. So the way that this works is the lightning effect has a VFX lightning effect spawner component on it. Lower this one a little bit. It's spawning a certain length of lightning in an axis aligned bounding box, and when it spawns a lightning, it spawns this prefab. So you can pass in whatever prefab you want. The prefab that I chose to pass in is this one, and it is a light with a really high intensity, and it also spawns this Altos light, which appends itself to an array on the GPU, which the clouds sample from in order to add point lighting to the clouds. So that's very cool. The other things that we've added are auroras. So these are these big aurora shapes, which you can position in the sky, and you can customize them as well. So you have different options like detail intensity, the brightness, the different colors that it has, the color distribution. So this will be somewhere between like here and here probably. It also animates the vertexes, so you can see that it waves a lot. If you set it really high, I recommend something normal. And you can control the tiling speed for the effect, as well as the vertical gradient strength and the radial gradient strength. And you can also control the scale of the effect. So these are auroras. We also have shooting stars. Let's see if we can find one. Let's go ahead and bring that spawn rate up. Sweet. So the shooting stars are these little guys. And then we also have comets now. So the comets are these big boys. That's a lot of comments. Okay. And all of these are integrated with the day-night system. So the VFX set time of day component, you can add it to any VFX in your project. When you do, make sure to have an Altos daytime factor exposed property on that. And then when you change the time of day, for example, to daytime, if you set the daytime brightness to something quite low, then you won't be able to see those VFX during the day. So that's the comets, the lightning, the rain, the snow. The rain has some effects, the snow has some controls as well. And okay, so for the wind zones to work, you need to make sure you add an Altos wind zone. It has a cloud speed modifier and a VFX modifier. So cloud modifier affects the extent to which the wind zone affects the clouds, and the VFX modifier does the same thing, but for the VFX. As for callbacks, I have a demo showcasing how to use callbacks with the system. So it gives some callbacks when the current period of day changed. So that's according to the period of day keyframes. And I think when the sun rises or sets as well. So you can subscribe to those when the day changes, hour changes, or period changes. So you can subscribe to those like this, just get a reference to the sky definition, and then subscribe to the on day changed, on hour changed, and on period changed events. And you can do different things based on the current period or day. Altos also now includes a reflection baker. So this baker automatically updates the local reflections so that reflections always look accurate. You should child this to your main camera. I didn't in the demo, but you should. And it automatically updates, every 1/10 of a second. You can control that. And it automatically updates every 1 unit change. And it automatically updates the environment reflections. And then also Altos is compatible with floating point origin offsets. So if you offset your origin by 5,000, then you can see that here we've just offset the cloud position by 5,000. So you'll just sync this up when you're doing a floating point origin offset. And for the weather system, I think we covered that. Let's see. So for some shaders, you might want to use the current time of day. So in order to use the current time of day, you're going to use the, let's see if I can grab it. Shaders. Great. So you're going to use the Altos daytime factor. So the way that you use this, just add this in your, whatever shader graph shader you want. And it goes between 0, which is when it's fully dark out, and 1, which is at noon, and then back to 0 when it's midnight again. So it goes 0 midnight, 1 noon, 0 midnight, like that. So a value of 0.3 is like a little bit before sunrise, and then 0.5 is exactly at sunrise. If that makes sense. So you just interpolate between those two. And here's an example of how you would use that in the Aurora Borealis shader. Let's see, what else do we have? Okay, so if you have any UI cameras or any other, cameras rendering things in your project, make sure to add the disable Altos rendering component to any cameras that you don't want to render Altos. This is really important, not only for performance, but it also guarantees that Altos won't render on top of other scene cameras, which is important as well. Okay, so I think that's pretty much everything I wanted to cover for Altos. As you can see, it's a fairly large asset. And if you have any questions, please leave those questions in the comments down below. And I'll include a link to the asset in the description as well. Great. So thanks for watching, and happy developing.